All right, so over the next several days, we are going to be learning in more detail about 3 types of what we call transformations. In these transformations, there will always be a pre-image, and then there will be a image. Obviously, the prefix pre talks about the before picture, so this is the original. And then after a transformation has taken place, it creates a new picture, which will be the image. Okay. A transformation in general, it's a way of what we call mapping the pre-image onto an image. And there are 3 types we're going to discuss in this unit. The first kind are translations. The second are going to be reflections. And the third are rotations. All right, so those are the big high school words that you have to use. And just to review, a translation, if you talked about this or remember talking about it in elementary and middle school, these are the transformations that look like a slide. Reflections look like a flip, and rotations are a turn. But we don't use those words, all right, but just so you have a visual of what they're going to look like. You need to use the proper vocabulary: translations, reflections, rotations. So in these next 3 pictures, all right, when you just look from one letter to the next, all right, hopefully you can tell that this letter A was turned, right? So this would be a rotation. The letter B is definitely flipped, and it was flipped over a line just like that. So this is a reflection. And then the letter C just looks like it was moved or shifted in that direction. So that is a translation. All right, so hopefully very simple like that, you can look at a picture and identify which type of transformation is taking place. All right, isometry. All 3 of these types of transformations are called isometries. And that simply means that it's a type of transformation where your pre-image and your image remain congruent. All right, so when you look at part A, all right, this picture was moved up, so that's a translation, but more importantly, they're the same shape and the same size. So letter A would be a isometry. B, all right, definitely it was moved, but it got either larger if you look at it that direction or smaller. So this is not an isometry. And then the musical notes, looks like they were reflected, all right, but again, they're still congruent, so this would be an isometry. So all you're looking for is, did the shape remain the same size and the same shape? Okay. Now, again, with any of the transformations, how they're labeled will help you understand which direction they are moving. All right, so there's a couple ways. This first one, you're going to see perhaps this arrow. And so what this means is that figure ABC, and this would mean is mapped onto, okay, or maps onto figure DEF. So this tells you that ABC is your pre-image, and that DEF is going to be the image. So it is definitely moving this direction. Okay. Now down at the bottom, I'm going to slide it up a little bit. So since it looks like it was slid to the right, that would be a translation. The pre-image, all right, will always be the first figure named. So the pre-image is figure ABC. And then the image is figure DEF. All right. This is asking just specifically for point B. And point B is being mapped onto, and if you come up here, there's two ways to identify it. It's the point on the bottom left, so we were looking for the point at the bottom left. Or you can go up here and slide back down. How your figures are named tell you how they match up. So if B is the middle letter in our pre-image, then it's always going to match with the middle letter of our image. So B is going to map onto letter E. Okay. So that's one way that you won't be able to identify pre-images and images. The other way is to look for the little prime symbol. So the figure that has just the regular old letters, that's the pre-image. When it has the prime, all right, which are these little tick marks that we see here, tick, 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 that's going to be your image. All right, so you'll notice when they're going to use the tick marks, they still use the same letters. So we know that G is going to go with G prime, and H is going to go with H prime, and so on. So in order for that to happen, this figure was definitely flipped or reflected over the y-axis. So down here, right, we can identify the transformation as a reflection. The pre-image is, again, look for the normal letters. Now, it doesn't matter where we start. I can start with any corner, but when you have 4 sides or more, you want to make sure that you continue naming either clockwise or you can name them counterclockwise from wherever you start. No zigzagging. No zigzagging. So I'm going to call this GHJK. So its image is going to be G prime, H prime, J prime, K prime. All right, again, the order in which you write them, this tells you how the corners of the shapes match up. All right, so G is going to map onto G prime, and J prime maps back to just the regular old J. Okay, so that's just some basics about transformations. Today, we're going to specifically talk more about translations. All right, so a translation is an isometry, right? Now, if you want, these are your notes. Remember, that means congruent transformation. So translation is an isometry that moves a figure the same distance in the same direction. All right, so it's moving a figure in the same distance and in the same direction. The word vector, when we're talking about a vector with a translation, a vector represents the horizontal and vertical direction of the translation. All right, so represents the horizontal and vertical direction of the translation. Now, there are 2 ways to be able to write the rule for a translation, okay? There's a component form, and there's what's called a coordinate form. The component form, you're going to see this capital T, which stands for translation. And then you've got these little, what I call little carets. And inside the carets, you're going to have the horizontal direction, comma, then the vertical direction. Very similar, think of an ordered pair, right? The X's run horizontal, the Y runs vertical. Okay, but you're going to have these pointy little carets around. So H represents the horizontal, which means how it's moving left and right. The V represents the vertical, which is how it's moving up or down. All right, sometimes the T gets removed and all you'll see is this. All right, this, and people call this almost like vector notation, but it's component notation. Okay. In coordinate form, what you're going to see is you're going to see the x coordinate plus whatever the horizontal component is, comma, and then the y plus the vertical. All right, and notice this has parentheses around it because it's going to look like an ordered pair. So in other words, if you saw this capital T and inside the vector we had 3, -6, all right, that would be the same if we wanted to write it in coordinate form as saying, okay, that would be x plus 3 because it's a positive 3, and then it's going to be y -6 because it's a -6. If you get rid of the T, then they might just show it like this with the carets around the 3 and the -6. Okay. So down here, we want to apply the following translation rule, all right, and then to actually translate the point or the figure. So if this is written in component form, so we've got the T with the -5, 4, that would be the same if I wanted you to write it in coordinate form as either x, then -5, since it's a -5, comma, and then it would be y plus 4 because it's a positive 4. It's just another way to write it. So here's point P. That means we're going to move, and this is going to take me actually off my grid, all right? But we would, I'm guessing I changed the numbers. We would come back, all right, to the left 5. So we're going to go 1, 2, 3, 4, 5. You probably can't see now, going off my grid. And then we're going to go up 4. So 1, 2, 3, I'm at the x axis, and then 1 above. Sorry that happened, didn't mean to go off the grid. So this would be our P prime. That's how we would label that, unless they told us to label it a completely different letter. Then we always just use the prime. All right, so let's figure out what that ordered pair is. So let's see, this was 1, 2, 3, 4, this would have been 5, 6, 7, 8, and then we went up just 1. So P prime is -8, 1. All right, the other thing, if we know this ordered pair, 1, 2, so this was -3, and then 1, 2, 3, -3. Notice the math you can do. You can take -3 minus, oh, I'm so sorry, -3 minus 5, and it puts us at -8. We can take the y coordinate -3 and add 4 to it, and that puts us at +1. So we can count and move and then identify, or we can figure out what it should be and then move it. Okay. All right, let's look at part B. This time I gave you the coordinate form. So I want you to write it in component form. So the capital T is already there, but inside the carets, then we would have a +1 and then a -3. All right. This time, let's do the math on the points. So coordinate A is -2 up 4. So if I applied this rule, I'm going to add 1 to -2. That puts me at -1. And I'm going to subtract 3 from the y coordinate. That puts me at +1. All right, let's look at point B. Point B is over at +2, +4. So if I apply the math, I'm going to do 2 plus 1, puts me at 3. And then 4 minus 3, again, has me at +1. And our last point, C, is 1, 2. And if I apply the math, I'm going to do 1 plus 1, moves me to 2. And then 2 minus 3 has me at -1. So this time, instead of moving and then identifying, I actually did the rule, and now I can go plot. So -1, 1. There's my new A prime. 3, 1. There's my new B prime. And then 2, -1. There's my new C prime. And when you connect, our triangles should still look congruent. Okay. And then lastly, instead of actually applying the rule, we should be able to look at a picture and identify what it is. All right. Now, when you look at the picture, notice one figure is labeled with normal letters A, B, C, and the other one has the primes, A prime, B prime, C prime. So we know the picture is moving in that direction. All right. So what we want to do, you could, if it was easy to count, right, we would just count over and then we would count down. It's a little hard. This grid is not the easiest. So let's just look at the A to A prime. And we only need to look at one letter pair because it should be the same for all of them. But to go from -9 to +5, what math is happening? In other words, and I'll fill this one in first, we're taking the X coordinate and then we are adding what? Well, to go from -9 to 5, we must be adding 14. Did I do the right math? Yes, I did. All right, to do the Y coordinate, to go from 9 to 0, we're actually subtracting 9. All right, and then we can check it out. Let's apply that rule to our C and C prime. -4 plus 14 puts us at 10, and 3 minus 9 gets us at -6. And we could do the same for B as well. All right, so there's our coordinate notation, and then all you have to do is inside the carets, we're going to have a +14 and a -9 to write it in component form. Notice this time I didn't have the T. All right, if it was there, great, but it doesn't need to be. All right, so now you should be ready to do some practice on transformations and then specifically translations as well.